I think this is our episode 81 or 82. So happy to host John Kennedy here. I'll tell you a backstory before I jump into the topic. John and I, we met at one of the meetups locally here in Seattle. And that's very rare to find someone who talks the language of vibe code these days. And most of them are talking about agents. They're talking about, but nobody talks about vibe coded slop. So I found the conversation very interesting. So today we're going to talk about the software factory moving beyond the vibe coded slop. John actually runs Actual AI. He is the founder of Actual AI, and he's been a veteran in the dev tool space. He's worked at AWS, Acquia, Upson, and his company. And I'll let him talk through that as well. His company enables his customers to essentially build software factory that's going beyond the vibe coding. So, John, welcome to the podcast. Tell me a little more about yourself, and then we can jump into the whole software factory model.
Yeah, thanks, Guru. Yeah, I've been building dev tools for the past 20 years now, and developers' needs have evolved really rapidly over the past couple of years. Back in January 2024, when I started Actual AI, and I was the only one coding the tool, all there was GitHub Copilot, really. And you had line completions. And it was like a tutor, it meant that you didn't have to remember syntax, so you go a lot faster. But then when we hit kind of Cursor coming into its own in June 2024, it completely changed the game. The conversational interface you could have inside your IDE really changed the velocity you could have. And that was a complete other mode of operation. And then when we hit January, February in 2025, and suddenly Devon became useful after being around for a long time. It started to become useful, and then we had Claude Code come along and really come into its own around the May timeframe. That completely changed the game again. And then by December last year, we really found that there had been a transition from kind of vibe coding, which included a lot of slop, to people who, even the best coders we knew, being able to not look at their code. And we think of that as agentic engineering. And that really, that was because they had put these very sophisticated harnesses around their process. And around the end of the year, you could see the best developers had that individual process they would use. But now what we're seeing is the ability for an organization to actually deploy a software factory, which takes that harness and moves it into the cloud so that you can have 24/7 operation, you can control your token spend, and you can put guardrails around AI-powered software development. So the mission of Actual AI has always been to help companies get to AI-powered software development in those various forms that we've seen along the way. And now there's a big opportunity for CTOs who want to actually build a custom, open source based software factory in their own cloud and their own VPC inside AWS, Azure, or GCP, or even on-prem, and get the acceleration that was possible before if you were an individual developer, but as a team at scale. So that's what's really exciting to us at the moment. And I think there's lots of ways we can help companies do that. We've built both a SaaS platform and a platform which can deploy agents inside of VPC alongside that open source software factory to actually help them get there.
Yeah. So, John, yeah, that's a lot of spiel. So, thank you for that. We'll maybe touch upon a few things one by one. And I may not be as aware of these terms. Maybe let's start with the term. I think you and I we touched upon the vibe coded slop. Could you maybe explain to me and maybe the audience on what does that mean? And we'll get to the software factory model. And I think I understand at a very high level, but maybe we'll take through the journey. Let's start with
Yeah,
the slop. What is
yeah,
the slop?
sure. Yeah. So slop has evolved over time. People still there's good reason to call kind of generated videos slop when they are obviously they have six fingers. People in them have six fingers, or more recently. You can see all sorts of videos that have been generated on YouTube that don't necessarily look entirely wrong, but they have very odd physics in them. They're actually they'll break your brain a little bit if you watch them on the generative side. In coding specifically, what we've seen is the models have improved over time. So originally, when you were using models to code, they would come up with all sorts of bad patterns, and you would ask it to build one component, it would build it one way. You'd ask it to build another component, it would build it a completely different way. Models have gotten better. Kind of default individual harnesses have gotten better, and so now they'll do some analysis of an existing code base before they start making decisions. But what we find now is that on sophisticated code bases, it's still very difficult for a model or an individual harness to conform to the decisions that an organization has made. And so what that leads to is a degradation in the architecture and a slowdown in deployment, because you might get the code written, it might even pass tests, but when you review it in detail, it's taking your software in a path that might not be scalable, or might not be secure, or might not be well written in a way that allows other developers or AIs to continue building on that code base. So, slop to begin with was completely breaking the code base. Nowadays, it can slow you down. It can waste tokens. It can, can break security paradigms. And there's still a lot of problems with people kind of just diving in. And this is why we have the paradigm of AI or guardrails for AI. There's lots of ways to do that on your own with harnesses that you can build on your own. And we also have a couple of approaches that include deep code analysis and this very specific concept, architectural decision records. ADRs are something that have existed for a long time, and we've built a system that is a system of record for ADRs with AI-based deep analysis to help you keep control of your code base and not produce AI slop, with using ADRs as guardrails.
Yeah, I think before we jump into the guardrail, so are you saying that slop was introduced because of inconsistent AI output? Meaning developer one runs a prompt and the output of that is something different than developer two, and then as it all comes together into the product, there's a lot of inconsistencies in how the code's been written, the packages that were created, the the structure of the code itself, maybe including the libraries that was introduced. Is that what you'd call it as? Is slop essentially an inconsistent behavior between various developers, or is that more than that?
Slop is anything that'll slow you down.
Okay.
The common types of slop are things where it's gone outside of the architecture that you've been using, or it's kind of using anti-patterns in the code. It can be between developers. It can even also just be the same developer giving different prompts, and the system not having good enough common context when it's building to be able to ensure consistency and conforming to the guidelines which the team is setting. So yes, it can happen between developers. It can happen with the same developer, and more, as we boot up software factories and they're running 24/7, you have to do an even better job of making decisions prior to kicking off those jobs, so that those factories don't go down completely the wrong path and end up with generating a lot of code that has to be rewritten. In fact, what we see on average is that people who boot up open source software factories like Gastown or other factories, they have to go through on average 4 revisions, where they have to they give it an issue that goes through and creates a PR all the way through architecture and design and planning and building and testing and reviewing. Goes through that whole cycle. They have to go through that cycle 4 times before they hit quality code, unless they have really strong guardrails and ADRs embedded in in their process.
Yeah, I mean, there's a backstory here, so maybe I'll share this. One of my SaaS founder friends, he runs an insurance SaaS company. They provide loans, they provide insurance on top of like debt kind of a funding, and he felt that his team was not using AI as much, so he went ahead and learned and I think took the Anthropic Skill Jar course, and he started writing code. And the
Yeah.
first thing he found was he found Anthropic to be a lot more expensive, so he went to Lovable, and then he went ahead and built a UI mock, and then he thought, hey, I can't take this to my developers; they won't even understand it. So let me go ahead and build. And he added Supabase to it. He added authentication to it. He added a whole bunch of things. For 2 weeks, he went on, and then he actually built an entire product. And then he was in conflict with his entire engineering team and the product team because the code base was very different. One was using React on the front end versus one was using Vue on the front end. Databases were different. Server side code was very different, so they could not integrate. So he decided to
Yeah.
go and actually go sell it himself. And this is very interesting. And the customer actually bought it, so they started paying $2,500 per month for that slop product that he built. Of course, with some
Wow.
results and all of that. And he's like, if I can build it and I can generalize it, do I really need my engineering team to be able to do something like that? Nevertheless, his engineering team actually pushed back on that because it failed security audits and tests and all of that. But now they are actually working towards fixing
Absolutely.
that. So
Yeah.
the story that you told me, it reminded me of this, and this happened just last week. So it's very interesting.
That actually happens all over the place. I think we're seeing a lot of power users prototyping now, and you can do that in Lovable, but you can also, download Gary Tan's GStack, and it
Yeah.
has a lot of kind of skills that make it easy for someone to go through the process of building a prototype with things like CEO review and the kind of office hours review and the engineering manager review. I think those tools, specifically Lovable and GStack and others like them, they're really good at the kind of net new code base, greenfield code base, and you can go off and build a prototype. And in some circumstances, it's great to use as a demo for clients. Even can be the starting point, or at least a way that you show your dev team, what you need them to build. But in the end, if you're building sophisticated software that's got to scale and it's got to be secure, then it ends up that you need a set of rules that are consistent across the code base, and it's much more effective and efficient to kind of include those upfront in your context and work with a wider team to kind of come to consensus on those, so everyone can be building the same way and the agents have the same understanding as the humans.
Yeah. So maybe let's talk about the rules. I think you mentioned about the word rules a couple of times.
Yeah.
So who's building these rules? Sure, I think for all the listeners, we'll actually put Gary Tan's GStack framework and
Yeah.
Cast and all of that into the show notes. But we want to touch upon the rules. Who's building these rules now? If everyone's writing white code, who's building those rules, and where do these rules essentially come into? How do you codify it? John, could you maybe share some thoughts on what these rules are, and how does can a product manager build his own rules? Can a UX engineer build his own rules? Can a customer success team or engineering team? Who's building these rules?
Yeah. ADRs have been around for a long time. And a lot of companies have posted blogs on them and talked about them, and they've usually been passive documentation that's lived in Confluence or in Google Docs. And usually what happens is some senior engineer will review some code of a junior engineer and say, hey, you're not conforming to our rules. Here's a link. Go look at the rules. And it's passive. It's after the fact. It's reactive. And every time a big decision is made, hopefully they update the documentation, but who knows if it's consistent with other rules. In the past, it's been very difficult to keep them up to date. ADRs themselves, we think of them as as very broad across all the different kinds of decisions that you can make. We actually have 72 categories of architectural decision record that are represented within our system. And the problems that we saw for people who are trying to take ADRs and actually offer them to agents so that agents could be consistent with humans were that it takes a lot, as I said before, to keep them consistent with your code base, actually to make those ADRs active documentation. And if they're not up to date, then they're actually in conflict with with keeping consistent code and consistent architecture. So keeping them up to date is hard. Having architectural coverage whereby you've made decisions across enough areas for the particular type of code base that you're writing, so that agents don't have to make big hard decisions on the fly. Getting that coverage is quite difficult as well. And then it can take a long time to write them, and understand what's already gone on in your code base. So, what we did is we built a deep analysis system, and it will analyze a code base for between 1 and 9 hours, depending on the size of code base, and come up with a set of rules that we think the team has already made in the code base. And that's across the 72 categories. And then you can spend a dedicated few hours on that initial task, which is accepting, rejecting, editing the ADRs as they've come in from the analysis. But once you've done that, we can automatically insert them back into your code base through a pull request. There's an advisor so that your agents can be connected in via MCP or CLI so that they have awareness of the rules. And there's also a code review that is just specifically for those ADRs, so that if any code breaches one of the architectural decision records, there'll be a comment in GitHub or GitLab, etc. And if putting those guardrails in place means that your agents write a lot better code. And everyone is using agents now, whether they're using them in the IDE or CLI or building an autonomous software factory. That has a huge impact on the quality of code, but it also significantly reduces down the token usage. Because if agents don't need to go through the whole analysis cycle to make architectural decisions, they're actually saving a lot of tokens, and there's less questions to the user, which means that you can have longer sessions running. And actually, ADRs are one of the key factors in being able to set up a 24/7 software factory, because once you have that architectural coverage, you can let agents go off and kind of build unattended.
So maybe let me ask, let's double click on this a little bit. I think in the previous days, probably John, you're aware of this, maybe you have experience this first time as well, but in my previous 2 startups, we used to hire principal engineers, and they were the custodians of the rightful architecture.
Absolutely.
And they would essentially go build these passive documents, as you said earlier, and then they would become a choke point, a bottleneck into all the reviews. Anytime a new feature is being built, the principal engineers, they would essentially get pulled in for code reviews, for design decisions, and all of that. So there'll be just calls and calls and calls, and the principal engineers essentially would not code, and they would complain back saying that, hey, I'm not able to code, I'm not able to ship anything because of all this. So now what you're saying here is that instead of the principal engineer creating a passive document, the workflow that has now changed because of what you have built is that they can codify using tools like Actual AI. It can automatically go review your code base, list down the decisions that are necessary, and then the principal engineers can review it, codify it, and make it part and parcel of any new build or any new development that needs to happen. Right, and that essentially reduces, or takes away, their time in the review, because the code itself can now be reviewed by LLMs rather than the people. Would that be right to assume?
That's absolutely correct. In fact, what we saw customers doing was they would hold this meeting once every 2 weeks to kind of do context engineering on their code bases to make sure that the right rules are in those code bases for agents. And it's incredibly time consuming, and it's very expensive in terms of a meeting, having all of the key people around the organization sit in that meeting. And what we've been able to do with the tool is make it an asynchronous process so that principal engineers can log in, they can see suggested rules, they can see updated rules where we're making a suggestion because something has been committed in code that makes it look like maybe you should update one of these rules. They can collaborate on them, they can leave comments on them, they can see the history of those ADRs. We're really a whole system of record for architectural decision records that has integration with all of the agent context file formats and all of the agents, so you can connect agents directly in. But all of that is to say that it makes the process a lot faster for principal engineers and improves the quality of code and reduces your token spend.
Okay, and who knows, maybe after some time you may not necessarily need the same principal engineer at all. Actually, I can actually do that work, and you can fire them. And
Hold on there a second. Some of the best, what I think a lot of people get worried about this. One of the best kind of AI or agentic engineers that I know, his process is that he's still specifying very specific algorithms because he's an expert in databases. And so I think there is still a role for principal engineers to think through, the ways to approach problems. But what we're doing is we're actually putting them a level up and allowing them to leverage their expertise much more quickly. Because if you can make a decision once and then never have to tell the agent ever again, then that's a much more highly leveraged role. And we actually think about this all over the place, the kind of stepping up of one derivative. Over time, software teams should be improving the velocity of the factory rather than just delivering code. In fact, what we tell customers these days is if you're not getting your engineers to spend at least 50% of their time improving the factory, then you're not actually reaching your potential. And what the system means for what our system means for principal engineers is they have a way to leverage their time across all the code bases in the organization really quickly and make high impact decisions and then enact them across all code bases.
Yeah. All right. So if you're a principal engineer and you're listening to this one, your job is safe.
You're okay. Yeah.
At least for now. So let me double down into, if an architectural decision can be codified in such a way, can a security decision also be codified? Testing decision, unit testing, functional testing, release testing, scale testing, even those can be codified. Would you say that these are also part of the ADR framework, or would that? What's the context? What's the scope of ADR in this case?
Yeah, when we think about open software factories that are kind of based on open source frameworks, there's a couple of patterns that have emerged that are really strong. One is this idea of parallelization. If you can run 20 to 30 agents at once per software factory and produce more code and then kind of deduplicate or deconflict code, you can go a lot faster. Another is test-driven development. If you can have the agents write the tests first and then have the test output feed straight back into the agents, then they can write better code. Another is this kind of persona-driven agents that do different tasks within the process. So we think about the process of planning, the process of architectural decisions, design decisions, building the tests, writing the code, reviewing the code, deploying the code, and then continuous improvement. And for all of those, you need different information and probably different agent personas and a different approach. So we really focus in on the architectural decisions, and they span, as I said, many categories. Within that, there's definitely architectural decisions you want to make that pertain to security, but also, say, in the code review stage, you probably want to use a dedicated security-focused code review tool. We do architectural review, but there are tools that are AI tools dedicated to security reviews as well. And when we kind of guide customers to build their own open source software factory based on these open frameworks, we'll guide them towards other tools for different stages in that process. We certainly want to help them with the architectural guidance, but there's lots of other tools to use and frameworks to help you build up each of those agents and the SaaSes that can plug in, or the vendors that can plug in to help you in those areas.
Yeah, I think maybe that brings us to a question. So I think there's a lot of rave. If you go to Reddit communities on AI agents and vibe coding, there's a whole bunch of skills that people publish out there. So there's a repository of, I think it's called skills.sh. You have more than 10,000 skills across the board. How do you say ADRs are different than skills? I mean, are they the same, or do you think it's all packaged together?
Oh no, they're quite different. So we publish skills. We have skills that we've published for our CLI tool. We have an open source CLI tool that actually will give you best practice ADRs even without doing the deep analysis.
Mhm.
And that you can install the skill and it will automatically install the CLI and pull the ADRs for best
Yeah.
practice for your particular code base. That's particularly useful on Greenfield where you've chosen the framework and you just need the kind of best practice ADRs for that framework rather than doing kind of building the custom ADRs for an existing code base. Skills kind of codify prompts,
Yeah.
and those prompts might call CLIs. They might have, they might imply some coding or have some code examples. That's really common. But, I would say that importing skills is a great way to try out different processes. But when you're building your software factory, then you actually need a kind of a higher level framework to trigger or to kind of build a pipeline and trigger process in that
Mhm.
pipeline. That may include skills, but a lot of the time you can build your own skills that are more custom for the software factory that you are building, essentially for the software that you're building. Your software, if you're a medium to large size organization, probably has its own characteristics in terms of scale and regulation and security and integrations and all these kinds of things. And building your own software factory helps to kind of zero in on the optimal factory for your organization and run that process of continual improvement so you continue to get higher and higher velocity. And so skills are probably a part of that story, but in the end, I think the skills you can download today are mostly good examples or mostly good ways to try out process, and you should be building your own skills for your software factory.
Yeah, so maybe I think we'll probably add some of the show notes on the skills. If you have any open source things around that, we can also add it over there.
Yeah,
Let's double down on maybe the next question. So the world is evolving very, very fast into all of this, right? So skills came in, and now you have the ADR frameworks that that you guys are promoting. Uh, how does anyone understand the ROI of all of this?
yeah,
Let's say there's a CFO, or even a CTO who's listening to this particular call. How do they make decisions on, you want to use this, you know, um, versus something else? And we'll take maybe a particular example. I think you and I, we touched upon an aspect of um, deploying actual AI for mid to a large size customer. And your value proposition was that you can go build a VPC only model, for that particular company. And by doing something like that, you will essentially get something back. There's some kind of an ROI. Could
yeah,
be, I think, just in this particular podcast about 10 minutes back, you mentioned about reducing the token costs, right? Or, or there's a cost savings in terms of how do you use Claude or wherever it is. But there could be other, maybe not necessarily measurable, like, better security, or better compliance or faster access to databases. So, maybe put your perspective on what's the ROI from something like this. Why would someone go build an ADR, a permissible ADR that you can deploy it as part and parcel of your VPC?
yeah. Well, just a note on why we deploy into VPCs into kind of your own cloud that you've built in
Mhm.
AWS, GCP, or Azure. We believe that CTOs need to be bringing the kind of the processes they've built, the knowledge they have around their own code bases to building an open factory, because they're going to get a lot more velocity if they build a custom software factory that runs 24/7 in the cloud that their developers can access instantly with full dev environments there and with all the characteristics that they know that they need, to actually continually improve that factory if they build it in their cloud. And there's a lot of data required for that, data from production systems, data from testing systems, integrations you might have, all the, the code base, your issue management system, all these systems need to feed data into this software factory. And so it
Mhm.
becomes very sensitive. It's got a lot of access, and therefore it needs to be inside your VPC. And that's why we deploy our agent alongside that inside the VPC, because we know that organizations need to keep that data secure. So if our agent deploys alongside that software factory inside the VPC, then none of the data leaves their cloud. So that's number one, why we do it in that manner. But two, the metrics, to the reasons, to the value that customers and CTOs are getting, it starts with velocity. Everyone needs to get to AI-powered software development. It's a completely different velocity. But some kind of ways to illustrate this, if you're doing a new project, and you mentioned it before, you can deploy something that's a fully functional prototype in days instead of weeks or months. That's a good illustration of the net new. For existing software projects, right now, if you dive in with Claude Code, you're likely to go a lot faster, but it might be on the order of magnitude of 2 to 3 to 4x faster. What we're seeing when people build a custom software factory is they're able to go 10x, 100x faster, because the agents are running 24/7, and you really step everyone up in terms of one level of abstraction. They can run fully automated processes from planning to design to testing to build, and it completely changes the velocity. And I think for software companies specifically, speed is the only moat now. It's become really cheap to create software. There's a great advantage in having distribution, but if you don't have speed, you're not going to make it. And the only way to keep up with the market is to actually be accelerating constantly. And the way that you do that is having a continual improvement process around your software factory. Absolutely, there's a metric around token spend. Right now, a lot of companies are taking advantage of credits they have with companies, or artificially low subscriptions from Claude or OpenAI. But I know the best developers we're seeing are spending along the lines of $10,000 a week in API credits, which isn't actually a crazy equation if you're getting that much velocity. But it means there's for a CFO, there's this huge opportunity if you can optimize tokens. And what we see with ADRs is that you can significantly cut the planning cycle. So you might cut between a quarter and a half the tokens out of the code generation process between planning and actual code generation. And in some cases, you might actually be cutting it down by 75%, because some software factories today, you go through a lot of iterations before you get to the final product, 4 on average, I was saying before. So there's a huge reduction in tokens. So, if you're spending a huge amount of tokens per developer, that's a big opportunity for the CFO if you can reduce down the token spend, or mean that the developer only has to use 1 Claude Max account instead of 4, which is commonly the case. And then, beyond the kind of velocity, the absolute velocity and the token spend, there's also when you cut down on human interaction, that unblocks a lot of your software development process. And so there's additional benefits to reducing the administration, reducing the kind of the back and forth that has to happen in software projects, which really comes back to velocity as well in the end. So velocity and cost, definitely.
Yeah, so velocity in terms of, you have an intent, you have an idea, do you release it to production, and we'll call it the time to manifest the intent. I'm just making up words here, but,
Yeah,
time to manifest.
that's a good term, yeah.
I think
Time to manifest.
Time to manifest your intent, right? So you dreamt of something and then it exists in production now. And you will be able to go measure that, in days now rather than in months. I think the second is the CFOs would be worried about the token usage. They would say thank you if the number of tokens have been reduced, or they are spending less on Claude, but still maintain the same velocity. I think the third thing that you mentioned is about, is it the lesser number of people or the handshakes between the people, based on the org size? It can be.
It can be. Yeah, it can be that you reduce down team size and have more, smaller teams for more projects. Or if, there's a lot of companies having to go through headcount reductions at the moment, that's a terrible thing to have to do. But if you have to, then this can kind of lighten the blow. I think what a lot of companies are doing, though, is actually increasing their velocity by having, smaller teams with and taking on new projects and rolling out new functionality and serving clients and customers more effectively.
Yeah, I think that brings back to, and we'll run out of time very quickly. So let me bring that back to what would you advise, anyone who's starting on this particular journey? I think there are two groups of people, right? The first one is all the greenfield apps, the people who are starting to work with Lovable, Bolt, and Windsurf, Replit for the first time, and then building, some small web apps. Any takeaways for them from this particular conversation versus the second group of people where they have an established code base, in production, they've been running software in production, what's the takeaway for them?
Yeah, I think for individual developers, they are probably using Claude Code at the moment with a combination of skills. What we've found is that we've built software factories that run in cloud, and even just for individuals on local laptops, there's still a really big benefit to be had by running a software factory 24/7, even if it's just for one developer. I've got to build out processes in the pipeline there, but individual developers can get a lot of velocity. I think for engineering leaders, they've got to be thinking about how they have every one of their software engineers evolve into software factory engineers that can improve the process of the software factory, not just write code, or not just kind of handhold the agent in writing code. What we're seeing is that companies are moving from linear delivery to linear acceleration, where they improve the speed of their software factory over time, and that's what keeps them competitive. And the only way to do that is to really commit to improving your software factory and improving your processes. So the kind of rule of thumb for us at the moment is, if you're not spending at least 50% of your engineering time building and maintaining and improving the software factory, you're probably not hitting the mark. That's really the advice that I'd give to CDOs. How can you get your software engineers to become software factory engineers? And are you putting in the time to make that happen? Are you kind of mandating the time in your sprints, etc., to make that happen?
Yeah, that's wonderful. So I think you're also doing some training around this, right? So sometime in April,
Yeah.
do you want to maybe speak through that?
Yeah, our first training is April 21 and 22. We're running it in conjunction with AI Tinkerers, which is a great group here in Seattle. We run the DevTools track for AI Tinkerers and get over 300 people register every month for that. We're running the training as a 2-day intensive on the 21st and the 22nd with a range of amazing speakers. It's a project-based learning approach. It's hands-on. Essentially, participants come with a project, and then we can help them turn that project into a project manifest for agents and a software factory manifest to help them build out a custom software factory, and then take them through the stages of understanding what an optimized individual AI workflow looks like, and how you build a 6-agent software factory, and then customizing each of those agents and then deploying that so that it can actually deploy their project. And by the end of the training, they have a working software factory they can run locally or in cloud that is actually deploying the project they originally specified, and essentially makes that a living project where you can put in a new feature request, and it kind of goes all the way into production with that feature request, with checks and balances along the way. So that's really exciting for us to be able to share the best practices we've learned building our software factories. And there's a lot of great speakers coming in from OpenAI and from other organizations who are really deep. Like Gas City is the kind of successor to Gastown. So we've got one of our main speakers is coming in who works directly with Steve Yagi on Gastown. He's coming in to kind of explain how to dive in on that side as well and build out Gastown, build out Gas City. A lot of really exciting speakers, and you can check out all the details on actual.ai/software factory. It's also available through AI Tinkerers. So if you kind of jump on the AI Tinkerers Seattle site or Seattle page on the AI Tinkerers site, you can find the training there as well.
Yeah, and we'll actually add it as part of the show notes as well. So John, thank you. It's wonderful to host you here. Thank you so much. I've learned quite a bit from this as well. And if you're a listener listening to this conversation, April 21st and 22nd is when John and his team are running the software factory training. It's in person, right, John?
That's right. We've got a beautiful space, lots of room for laptops. It's a very hands-on workshop. We're going to have facilitators circling around the room to help you with your setup specifically. We've got workshop format, lab format. It's meant to be intensive, so you get a lot of learning out of that short period of time, that 2 days. And we love it when CTOs want to send along teams of 3 and 5. Individuals can definitely come along. We'll help you, but if you bring teams along, then they all get to learn the same techniques and go faster all together.
Yeah, and get your AI scores up. Again, thank you so much, John. We'll put the link in the show notes as well, and we'll have the recording in about a week or two. So thank you so much. We'll see you soon.